All right, so for today's lecture, we are looking at March 14th. We're doing a lab in our physical science classes. We're looking at real-life applications of calorimetry. Calorimetry can be used to determine an unknown substance. It can be determined unknown compounds, whether they be liquids or solids. So these do have real-life applications, especially if you are trying to solve a hit-and-run case, or if you're trying to solve any other type of like what kind of metal or what kind of casings are made of. So let's go ahead. Everybody did get a worksheet. It's about 3 pages or so. First step is to kind of click on this link, and here we are. So go ahead and click on experiment, and you'll see run demonstration or run experiment. You are supposed to click on run demonstration, so we'll go through this. So follow the step-by-step procedures. They make it pretty foolproof. They kind of tell you what to measure out over here to the side, and the arrows kind of point on where you're supposed to be at. So we have 2 samples of water, and they are at 2 separate temperatures. Go ahead and click the show specific heat here at the bottom. That way you can kind of see what they are, and that will come in handy later on when you do your calculations. Also, make sure to record everything you do here. So we have our 2 samples of water. Both are at 100 grams and are at 2 different temperatures. So let's go ahead and run the experiment. And it takes a little bit of time. You see the hot water is being poured into the cooler water, and you'll see that the mixer is mixing everything together, and we're waiting for that final temperature. You see that the temperature is going up. And our final temperature is at 35 degrees Celsius. So we'll see that the next question is, which substance gained heat? As we go through here, you can actually see the questions are off to the side. And let's go ahead and let's answer this incorrectly. Let's say neither substance gained heat, which we know is completely false. One of the 2 had to gain heat. Here, they even give you the correct answers, so don't worry about getting answers incorrect at first, because they will go through and they will explain why. So we know that the water gained heat, the water that was at 20 degrees Celsius, because look at our final temperature. I mean, it obviously went up from 20 degrees. So let's go through. Let's make sure that we answer our question here. Which substance gained heat? Water at 20 degrees Celsius. Next up, it's asking you to sketch a graph. When you go through the demonstration is kind of difficult since it only allows you to pick and choose certain buttons. But as you go through, you'll see here, it's showing you now. Click on the Show Graph button, and it'll replay the experiment, and you can see here, temperature of hot water is losing energy while the cold water is gaining energy. You can take a screenshot of the finished graph, and you can put that here. So you can definitely take screenshots, or you can try your best to sketch it out. That will work as well. All right. So next question was, did the 20-degree sample of water change more in temperature than the 50-degree sample? Well, this particular question is actually best shown while looking at the microscopic view. So again, we'll say yes, which again is an incorrect answer, simply because I would like to actually show the microscopic view. So we have the correct answer shown as no, the change in temperature for 20 degree sample water was the same as the change in the 50 degrees. And you can kind of see that because our graphs are fairly equal. But let's look at this. Let's look at the microscopic view and see what's going on here. You can see that our hot particles are these bright red, and the cold particles are these kind of pinkish ones. And you can see, you can pick any dark red one, and you will see that they will eventually become pinkish. And that's showing that transfer of energy. All right, so again, our next question is going to ask about describing the motion and clicking all that apply. We can see that the water molecules at the higher temperature slow down, while water molecules at lower temperatures tend to speed up a little bit. We know that they're not all going to act the same way, and we know that there is not all no change. So we'll reset the experiment. Again, the demonstration kind of will walk you through everything. So don't worry too much about getting wrong answers. Just make sure you're recording the information, and if there's any issues recording data, or if there's any issues in the experiment at all, just let me know and I can kind of help you all through it. But make sure, above all else, make sure you kind of have a good day.